Hello everybody, myself Prashant Mukhopadhyay, faculty member, Electrical Engineering Department, Greater Kolkata College of Engineering and Management. In our last class of power electronics, we have discussed about, in the last class we have discussed uninterruptible power system, a power supply, and where we have discussed about what is the need, what is UPS. Basically, it's what are the types of UPS, what are the major roles of the UPS, and lastly, we have discussed about offline UPS system. And not only that, in the last class we have discussed about static circuit breakers. So both static DC circuit breakers and static AC circuit breakers. So today we'll start a new topic, that is not only the new topics, the continuing portions of the UPS, that is online UPS and other different types of UPS, their applications, and static power compensation system or static power controller. Now, online UPS system, today we'll start with this online UPS system. Now, this type of UPS, it's actually a double conversion method is used. The first AC input is converted into DC by a rectifying process for storing it in the rechargeable battery, and this DC is converted into AC by the process of inversions and given to the load or equipment which it is connected to. Basically, this is shown in figure 2 later on. And this type of UPS is used where electrical isolation is mandatory. This system is a bit more costly due to the design of constantly running converters and cooling systems. Here, the rectifier, which is powered with the normal AC current, is directly driving the inverter. Hence, it is also known as double conversion UPS, and the block diagram here it is shown. So basically, this is the block diagram. This is the main. This is rectifier unit, which say convert AC to DC, and then this DC is being used for say charging or storing energy in the battery, and then this stored energy, this is reversible. When it is required, it should be stored, and when it is this is not in the main is interrupted, then this will be say given to the input as the inverter. So inverter, it is DC, so it is also DC from rectifier, and from battery it is input is DC coming from the battery in the inverter, and the output is the AC, and this AC is given to the load. Okay, and this is the static bypass system. So when if you want to bypass this one, so you the main is directly supplied to the load. So function is that when there is a power failure, the rectifier has no role in the circuit, and a steady power stored in the batteries. Okay, any power failure, the rectifier has no role in the circuit, and a steady power stored in the batteries, which is connected to the say inverter, is given to the load by means of the transfer switch. Okay, once the power is restored, the rectifier begins to charge the batteries, and to prevent the batteries from overheating, say due to high power rectifier, the charging current is limited, and during a main power breakdown, this UPS system operates with zero transfer time. The reason is that the backup source acts as a primary source and not the main AC input, but the presence of inrush current and large load step current can result in a transfer time of about 4 to 6 milliseconds in the systems, whereas we have seen that in case of offline say UPS, this time period is not less than 25 milliseconds. Okay, now say actually 4 to 6 milliseconds in these systems, and this is, once again I'm telling you, this is actually online UPS, And in this type of UPS, a double conversion method is used, as I shown you. The first AC input is converted into DC by a rectifying process for storing it in the rechargeable battery, and this DC is converted into AC by the process of inversion and given to the load or equipment which it is connected to. And this type of UPS is used where electrical isolation is mandatory, and this system is a bit more costly due to design of constantly running converters and cooling systems. And here the rectifier which is powered with the normal AC current is directly driving the inverter. Hence, it is also known as the double conversion UPS. And this is the block diagram, as I told you and I explained you this. And there is any power failure, the rectifier has no role in the circuit, and the steady power stored in the batteries which is connected to the inverter is given to the load say by means of transfer switch. Once the power is restored, the rectifier begins to charge the batteries, and to prevent the batteries from overheating due to high power rectifier, the charging current is limited, and during a main power breakdown, this UPS system operates with zero transfer time. And the reason is that the backup source acts as a primary source and not the main AC input. But the presence of induced current and large loads step current can result in a transfer time of about 4 to 6 milliseconds in this time. Now, LineInteractive UPS. So for a small business and departmental servers and webs, LineInteractive UPS is used. This is more or less the same as that of offline UPS. And the difference is the addition of a tap changing transformer. Voltage regulation is done by this tap changing transformer by changing the tap depending on input voltage. And additional filtering is provided in this UPS, result in lower transient loss. The block diagram is here like this. This is utility input AC. This is tap changing transformer. Required after tap changing, you can get required AC here. Then it is filtered, and this from different harmonics and noise, and this will be given to the UPS output. So this is UPS going to UPS output. So this is actually bidirectional converters. So you can get, say, either this is AC, this AC. Bidirectional means when it is used as say for getting as a rectifier, so AC will be converted into DC and stored in the battery, and when it is required to supply the AC to the tap changing transformer, so then say battery DC will be converted into AC, and this AC will be given to the tap changing transformer, and this will give, after say filtered, it will be going to as a UPS output. So this is the block diagram of say LineInteractive UPS. And if you talk about the UPS applications of UPS include data centers, industries, telecommunications, hospitals, banks and insurance, and some special projects or events also. That's all about this UPS. So once again, if we have a look of the entire uninterrupted power supply systems, what we have discussed in the last class and in today's class, so have a quick recapitulations of the entire UPS. We'll see this is what is this. So basically, uninterrupted power supply is defined as a piece of electrical equipment which can be used as an immediate power source to the connected load when there is any failure in the main input power source. And UPS, the energy is generally stored in the flywheels, batteries or supercapacitors, and when compared to other immediate power supply systems, UPS has the advantage of immediate protections against input power interruptions, and it has very short on battery run time. However, this time is enough to safely shut down the connected apparatus, that is computers, telecommunication equipment, or to switch on a standby power source. And UPS can be used as a protective device for some hardware which can cause serious damage or loss with a sudden power disruption. Uninterruptible power source, battery backup and flywheel backups are the other names often used for UPS. And the available size of the UPS units ranges from 200 volt ampere, which is used for a solo computer to several large units up to 46 MB. The major roles of the UPS, where there is any failure in the main power source, the UPS will supply the power for a short time, and this is the prime role of the UPS. And in addition to that, it is also able to correct some general power problems related to the utility services to the varying degrees. The problems that can be corrected are voltage spikes, that is sustained over voltage, noise, quick reduction in input voltage, harmonic distortion, and the instability of frequency in bands. And types of the UPS, generally the UPS system is categorized into online UPS, offline UPS, and LineInteractive UPS. And other designs include standby, online, hybrid, standby, ferro, data conversion, online, etc. Offline UPS we have discussed in this is called standby UPS system, which can be give only the most basic features. The primary source is the filtered AC mains, and when the power backup breakage occurs, the transformer switch will select a backup source that is shown in the block diagram in the dashed line, and thus we can clearly see that the standby system will start working only when there is any failure in the mains. In this system, the AC voltage is the first rectified and stored in the storage battery connected to the rectifier. When power breakage occurs, this DC voltage is converted into AC voltage by means of a power inverter and is transferred to the load connected to it. So this is the least expensive UPS system, and it provides surge protection in addition to backup. And the transfer time can be about 25 milliseconds, which can be related to the time taken by the UPS system to detect the utility voltage that is lost. And the block diagram here, it is this is the main part, main surge suppressor, then filter, then it is going to the load, which is the transfer switch when the power failure is there. So this will be connected here, and this dash line shows the rectifier unit where AC is transferred into DC and the energy is stored in the battery, and then from say this is inverter unit DC to AC, it will going to this say load through this transfer switch in case of power failure. And online UPS, and in this type double conversion method is used. First AC input is converted into DC by rectifying process or for storing it in the rechargeable battery, and this DC is converted to AC by the process of inversion and given to the load or equipment which is connected to. And this is shown in the figure 2, and this type of UPS is used where electrical isolation is mandatory, and this system is a bit more costly due to design of constantly running converters and cooling systems. And the rectifier, which is powered with the normal AC current, is directly driving the inverter, hence it is also known as a double conversion UPS. And the block diagram here, it is, so this is the as I told you, then it is this is a rectifier unit which is converting AC to DC, and this DC is stored as in the battery, and during the time failure this DC will be given to this inverters as input, and output AC is supplied to the load. And in case of this if you want to bypass this system, so this is a static bypass system. So because of two converters and the cooling system, the unit is a bit costly, and so charging current is required, should be limited to say get rid of overheating. So LineInteractive UPS for small business and departmental servers and webs, LineInteractive UPS is used. This is more or less the same as that of offline UPS, and the difference is the addition of a tap changing transformer. Voltage regulation is done by this tap changing transformer. So by changing the tap depending on input voltage, an additional filtering is provided in this UPS, result in lower transient loss. The block diagram is like this. So this is actually AC utility input. This is tap changing transformer. So required say AC voltage will be given, it will be filtered, and then say it will be the UPS output. And this bidirectional converter will be used this basically for charging of this battery and storing this. So this will be this will work as a converter, rectifier, and during power failure This bus D will supply the DC input, and the output AC will be going to the transformer, and required voltage will be will be as output for the load as UPS output. So this is actually the LineInteractive UPS. Now UPS applications are several applications are there, and this includes data centers, industries, telecommunications, hospitals, banks, and insurance, and some special projects events. So that is about the UPS, uninterruptible power supply. So we have studied what is this, what is its needs, what is the major roles of it, what are the different types of UPS, and we have discussed and working of these different types, that is offline, online, LineInteractive UPS, and also we have discussed the applications of UPS in this topic of UPS. So hopefully you have understood this, and if you have any problem, you can, after study, you can ask me later on. Okay, now we'll discuss about a new topic within this unit. Actually this is a static power controller or static power compensator. So what is actually a static power compensator? A static power compensator is a parallel combination of controlled reactor and a fixed shunt capacitor. So that is shown here. So, and the thyristor switch assembly in the static power compensator or SBC controls the reactor. So the firing angle of the thyristor controls the voltage across the inductor and does the current flowing through the inductor. So in this way the reactive power drawn by the inductor can be controlled. So basically this is actually the static power compensator. This is bus bar. So this is actually transformer. So this is actually fixed capacitor, and this is the unit. This is the inductor L. So as I told you, it is a parallel combination of controlled reactor. Okay, it is this reactor is controlled reactor and fixed capacitor. So this is a fixed capacitor. So thyristor switch assembly in here. This is actually in this static power controller controls the reactors. So this reactor is being controlled. So the reactor is being controlled means the current through this reactor will be controlled, and as a result the reactance value is also be controlled. Okay, and this how it is controlled? This thyristor switch SVC, actually the firing angle of this thyristor control the voltage across the inductor, and thus the current flowing through the inductor is being controlled. So in this way reactive power drawn by the inductor can be controlled. So once again I'm telling you, so SVC is nothing but a parallel combination of controlled reactor and a fixed shunt capacitor. Okay, and why it is a controlled reactor? Because this current through this inductor will be controlled by this unit. So this is the thyristor. By controlling the firing angle of the thyristor, so voltage across the inductor will be controlled, and the current flow through the conductor in inductor will be controlled. So in this way the reactive power drawn by the inductor can be controlled. Okay, so this SVC is capable of a step-less adjustment of reactive power over an unlimited range without any time delay, and as a result it improves the system stability and system power factor. So most commonly used SVC schemes are thyristor control reactor TCR, thyristor switch capacitor TSC, self reactor HR, thyristor controlled reactor fixed capacitor TCR FC, and thyristor switch capacitor thyristor controlled reactor TSC TCR. And also advantages of the static power compensator is it increased the power transmission capability of the transmission lines. It improves the transient stability of the system. It controlled steady state and temporary overvoltages, and also it improves the load power factor and therefore reduce the losses and improved system capability. Okay, so that's all about this actually say static power compensators. So once again I'm telling you this SBC may be of TCR, that is thyristor control reactor, thyristor switch capacitors, TSC self reactor, SR thyristor control reactor, fixed capacitor TCR FC, and thyristor switch capacitor thyristor control reactor TSC TCR. And advantages of this static power compensator is it increased the power transmission capability of the transmission lines. It improves the transient stability of the system. It controlled the steady state and temporary overvoltages. It improved the load power factor and therefore reduced line losses and improved system capability. And also static power compensator has no rotating parts and is employed for surge impedance compensation and compensation by sectionalizing a long transmission line. Okay, so actually these are all about static power compensator. Okay, so with a quick recapitulation, so what actually we have learned in this unit 7, that is after studying entire power electronics and its application portions of this unit. So basically we have studied this portions, that is speed control of AC and DC motors, then HVDC transmission, static circuit breaker, UPS, and static power controllers. Under this we have thrown some light about the applications of the power electronics, what are the applications area. We have shown here application of power in different this diagram. Then we have discussed about a little bit about this the applications. Then so application list is enormous, so that is starting from automotive and traction, that is within this you have subways, hybrid electric vehicles, forklifts, electric power steering, ships, modern traction systems, etc. Then we have industries, that is including rolling mills, elevators, pumps, cement mills, construction machineries. Then wind system for renewable energy, wind system, solar system. Then defense and aerospace, that is satellites, space shuttles, aircraft. And then utility systems, so smart grids, facts, HVDC transmission, and in our daily life, so that is vacuum cleaners, UPS, computers, air conditioning, etc. We have shown this application area of power electronics. Then we have gone to the speed control of DC motors. So where we have discussed about the single phase DC drives, three phase DC drives, chopper drives, etc. And also we have shown how this the block diagram of the speed control scheme of say, then classifications of the regulated power supply system we have shown. Then methods of the DC motor speed control we have discussed, where we have discussed the speed control of DC motor, single phase separately excited drives. Then how it we have discussed in details about its circuitry and its functioning. Then single phase half wave converter drives also we have discussed the circuit diagram, its waveform. And then single phase full converter drives also we have discussed, that is circuit diagram and different waveforms of this. Then DC chopper drives, where we have discussed the principle of working, circuit diagram and waveforms also we have discussed. Then various speed control methods of the different motors, that is speed controls of this. Actually this is the block diagram or classification of the speed control motors, say that is also shown. Then AC motor speed control with this with a small short introduction with the construction of this motor, and then AC speed control motor system, how it works, then principle of the speed control from its say operational formula, then its speed torque characteristics, then simple voltage control methods, its waveform, voltage change by transformer, voltage change by phase control. Then track control circuits also we have discussed. Its block diagram of AC speed control motor systems also being discussed in this unit. Then the waveform of each block of this motor control systems, that is speed control of the motor system. Then operation of the speed control systems also we have discussed, and its characteristics etc. we have discussed. Then rotational speed torque characteristics, then brushless DC motor control unit, its construction of brushless DC motors, then how principle of speed control of the DC motors, rotational speed torque characteristics of the brushless DC motors, output part of the control unit, and driver, then switching sequence, etc. And block diagram of brushless DC motor systems also we have discussed. And also we have discussed the comparison of voltages applied by sine wave drive method and 120-degree drive methods. And then also we have discussed the characteristics, inverter speed control unit. That is, under this we have discussed about the principle of the speed control, then actually what is the waveform, this duty control of on and off. Then we have discussed about the open loop control systems, the speed control, that is block diagram. Then VYF control, closed loop control, it's a block diagram. Then characteristics data table also we have discussed certain characteristics data tables, and after all we have given the summary out of it. Then we have gone to the HVDC, power electronics application in HVDC systems. Why HVDC, how it work, what is the needs, what is its components, what is its advantages, and what are the disadvantages also we have discussed in HVDC systems. Okay, so components, different components, it is converters, moving reactors, harmonic filters, reactive power supply, electrodes, DC lines, AC circuit breakers, etc. we have discussed. Then in details of these components, then we have gone to the next topic that is covered up in here. Actually this static circuit breakers. So static circuit breakers, so this is static AC circuit breakers, static DC circuit breakers we have discussed. And also we have discussed the UPS system. So UPS, its roles, major roles, types, offline UPS, online UPS, LineInteractive UPS, then UPS application. And lastly we have talked about this static bar compensator unit. So after what are the different types of static bar compensator units, how it works actually, and what are the advantages of static bar compensator unit. So with these discussions we may conclude our sessions on this applications part of the power electronics under this unit, and hopefully you have say understood it. If you have any problem, you can, once again I'm telling you, after reading, if you find any problem, so you may contact me, and either by mailing me or WhatsApp me or directly phoning me. So everything is given in my lecture. So video lectures, every address is given, and I have taken the help of the textbooks. So Muhammad Rashid, P.S. Bhimra, PC Sen, and different materials from NPTEL, internet, etc. So I hope that you have understood it, and if you study it carefully and take the help of your textbook, it will be easier for you to understand the subject. So thank you all. Thank you once again for giving the patient hearing of this lecture. Thank you.